We're going to look at the inverses of trig functions. So today's question is, here's a sine ratio, 1/2. What is the angle? Now, you might remember, oh yeah, I know that somewhere, and you look it up on your table and you see, oh, sine pi over 6 is equal to 1/2. But then you say, wait a minute, if I look at the sine of 5/6 pi, that's 1/2. But if I add 2 pi to that, that's also going to be 1/2. Well, and if I subtract 2 pi, that's going to be the same thing because it's periodic. So the problem is, what angle do you want? Okay, and we're going to come back to that. And imagine I give you, so you may know that when you 1/2, but what if I said, what angle goes with, or what angles, right? Because there's more than one, go with sine ratio equaling 2/3. Now that's not one of the common ones, so we wouldn't know that. So we're going to come back to that question. Okay, but first I want to go into the theory about this. So this is going to be a theory video. Okay, so this should recall, remember we had something like this. So what is the exponent of 10 that gives me 93? I don't know the answer to this offhand. So that is the same as solving, well, 10x equal 93. But we have it. We have a function there. Well, remember you take the log base 10 of 93, and that'll give you x. And it's about 1.9, somewhere in there, as I remember. So it's probably not a very good approximation, but it's a good guess, because 10 squared is 100. But anyway, we have a function that does that. And I kind of want to remember that the log 10 of 93 gives us the exponent of 10 that goes with 93. Okay, so we're asking the same sort of question here. Let's go back to here. We know that the sine of x is equal to 1/2. What is x? So again, we're plugging in the sine. You plug in an angle, and you get a ratio. So we want something that we plug the ratio into and get the right angle. So we're going to have something which I'm going to just call inverse of sine, and I'm going to plug in this 1/2, and it's going to give me the angle or angles that go with this. Okay, so again, there's going to be a lot of angles that go with. There's going to be a lot of angles, but here's the upshot. Here's the point I'm trying to make, is that we have the sine of an angle, and that gives us a ratio. Now we have the inverse sine of a ratio, and that's going to give us an angle. So again, they're kind of like, they're opposite of each other. So when I want to solve sine x equals 1/2, I plug 1/2 into something which we're going to call the inverse sine. Again, we're going to use different notation for that. And so I get that, and this will give me the angles that work. The angles whose sine ratio is 1/2. And again, we saw that it's going to be lots of angles. It's going to be pi over 3, pi over 6. It's going to be 5 pi over 6. And if we add plus or minus 2, if we add 2 pi to each of those, we get another answer. And so if we subtract, so there's a lot of different solutions to that. That should be pi over 6. Okay, so now another way of saying this, when we look for the inverse of the sine, we're going to have a problem. So we're going to have to fix that problem. Okay, so let's look at the graph. and I want to propose a solution to the problem of finding an inverse. Here's the sine function. It's not 1-to-1, so its inverse, the inverse of sine, is not a function. Okay, now think about this. However, if you plug that into, go get a calculator or calculating device. Here, let's just go to Desmos for a second, and we'll plug this in. I'm going to do something called, again, we'll worry about this notation later, but this is the sine inverse. Oops. I'm going to plug in 1/2. And it's hard to tell what angle this is, but that's going to be equal to pi/6. So look, I plug a number into the sine inverse, and it gives me back one number. So something's going on. So what this means is that Desmos is treating this quantity like a function. So I want to explain what's going on. And if you go to any calculator, you're going to get the same thing. Think about it. A calculator gives you one answer. So a calculator is treating your input like a function. Okay. We'll come back to that. So let's stop the share. Okay, so here's what goes on, is that what the sine inverse does is it starts here, and it's just going to look at only this part of the sine curve. Now notice that this covers, here I'm going to put my, here I have -1 pi/2. Pi/2 and 1, I'm sorry, 1 and pi/2. This is the sine. Okay. Okay, so this covers all possible sine ratios. So we're just going to look at this particular part of the sine, the part that I did there. So y equals sine x, where x is between 90 degrees, -90, and positive. That gives me all possible ratios. I'm sorry, you know what? I really screwed this up. I had this backwards. I had it right the first time. We plug in pi/2, and we get back 1. This is the point pi/2, 1, and the same thing here. Sine of pi/2 is equal to 1. Plug in an angle, you get a ratio back. Okay. Again, that's important. So let's fix that. So this point is going to be pi/2, 1. That's the endpoint here. This is going to be minus pi/2, 1. So if I take any random point here, I have an angle for the x-coordinate and a y. The y-coordinate is the ratio. Okay. So here's the inverse of sine, and this is one way to write it. It's the way I like to write it. Okay. Now there's other ways to write it too. Here's what its graph is going to look like. It's going to, if you look this up, and we're going to do this in a second, it's going to look something like this. It's going to look similar but different. And so again, we're going to plug in here a ratio and get back an angle. So it's going to be the opposite of that. So this point here, we're going to plug in the ratio of, that should be -1, sorry, -1, and we're going to get back the angle that goes with it, which is minus pi/2. Here, we're going to plug in the positive ratio, and we're going to get pi/2. And if I plugged in 1/2 here, the sine ratio of 1/2, it's going to give me back pi/6 or 30 degrees. Okay. So I'm going to go jump to Desmos and look into that and try to explain that again using Desmos. I think it can be really helpful. Okay, so here's the share with Desmos. Here's the sine. Okay, and again, that has just too many values. Okay, so we need to restrict it so we get one complete cycle. And the way that I'm going to do that is here. I'll just add something. I'm going to graph the sine again, and I am going to specify my values. We're going to have minus pi over 2 less than or equal to x, less than, I don't know what happened there. I think I do, but it doesn't really matter. Less than pi over 2. Okay, and I'm going to just take that away. See, that's one complete cycle of the sine. That covers all possible sine ratios. Okay, now I'm going to graph below that the inverse. So you can look at some of the points here. You can see -1, minus pi over 2, pi over 2, 1. Okay, and so forth. Okay. So again, I'm going to add another item right below that. I'm going to add the function sine. And remember, this is not the reciprocal. This is the inverse of the sine. And notice what its graph looks like. Here, let's just bring this down a little bit. Here, let's take off the sine. And here, the endpoint, we plug in 1, we get pi over 2 back. Plug in -1, we get minus pi over 2 back. Plug in 1/2, if I can find 1/2, we get pi over 6 back. So again, I just want to point this out. I want to add a note, and I'm going to hear that the sine inverse, we plug in a ratio and get back an angle. And the angle is going to be between minus 90 pi over 2 and plus 90. Okay, so here's my example. Sine minus inverse of 1, didn't do that right, 1/2 is equal to, again, that's going to be pi over 6 radians. Okay. Notice with the sine, you plug in an angle and get back a ratio. Let's do an example of that. Sine inverse, we want the sine of pi over 6 is equal to 1/2. Okay. Now with the inverse of the sine, you plug in a ratio and get back an angle. Okay. So again, we just want to know these. We just want to make sure that you know these values, and you can just go down there like that. Okay. And I'm going to summarize things at the end. Okay, now the graph wasn't quite here. I'm going to go back to the graph that I had. It wasn't perfect. But here's the graph that I have. It should have been more like this and more like that. So sorry that wasn't a great graph. Okay, so we're going to do the same thing for the sine cosine and tangent. So just to summarize for the sine, we have, when we look at the sine inverse of x, that's going to give us a number y. That's going to be a ratio, a sine ratio. And that's going to be the angle that goes with it. Okay, and then, so x, the only possible sine ratios are between x, between -1 and 1. Here, I'm going to try to get that so it focuses better. Okay. And then the angles are going to be between minus pi over 2 and pi over 2. So that's how we have to interpret it. Okay. Here's what we're doing is we're inverting this particular part of the sine graph. that has all possible ratios. And then what we're going to get back is going to be what's called the inverse sine. It's going to look something like this. Its x is going to be a ratio between minus 1 and 1, so that's going to be a ratio. And what we're going to get back is the angle. And our angle is going to be between minus 90 and plus 90. Okay, so sorry. Okay, so that's it. I'm going to do each of these separately, 3 short videos. That's the inverse of the sine. So good. So the next video will be the inverse of the cosine. Okay, sorry, it took me a second to find the end here. Okay, see you soon.